Section 1.5, solving linear equations in one variable. So we're going to start by looking at, is -5 a solution to this equation? So what we need to do is plug in our -5 for our variable and see if it works. So 2 times -5 minus 3 equals to -13. 2 times -5 is -10. Minus 3, so -13 equals -13. So yes, it is. If you got two numbers that didn't equal each other, your answer would be no. Alright, so when we solve equations, it's like balancing a scale. What you do to one side, you have to do to the other side. And this is key. When you move from one side of the equation to the other, you want to go in the opposite order of operations. So this first one, last in order of operations was addition and subtraction, so that means it's first here. So we want to go ahead and subtract 15 from both sides, because our goal is to get this a by itself, so we need to move things away from it. So -3a equals 0 minus 15 is -15. Now between this -3 and a, we've got multiplication. Opposite of multiplication is division. So we'll divide by -3. On this side, -3 divided by -3 is +1. -15 divided by -3 is +5. So a equals 5. On this next one, first off, we need to distribute because we need to get all of our grouping symbols out of the picture before we can add or subtract from both sides. So first off, when we distribute this -2, we get -2a minus 6 equals 18. Now it's very similar to the last one we did. So we need to move the 6. You add your 6, do your addition and subtraction first. So I have -2a equals 18 plus 6 is 24. And then we still have multiplication going on here between our -2 and our a. So we divide by -2, divide by -2. And a equals -12. Alright, so this one, it looks more complicated. However, it's following the same idea. We want to distribute first. Get rid of our parentheses. So I'll have 3/2 x minus, and now notice when you do 3/2 times 2 over 1, our 2's will cancel and we're left with 3. And then on the right side, 5/3 x minus, same idea, 5/3 times 3 over 1. Your 3's cancel, 5. And then we still have this plus 2 at the end. Notice the 2 is not in parentheses, therefore it is not getting multiplied by that 5/3. And let's delete these. Alright, now, nobody likes dealing with fractions. So the easiest way to not have to deal with them anymore is if we had to find a common denominator, what would it be? Well, notice we've got a denominator of 3 and a denominator of 2. So our common denominator is going to be 6. So multiply both sides of the equation by that number, which in our case was 6. So on our left side, when we do 6 times 3 over 2, that is 6 over 1. So our 2 is divisible by 2, we'll have 1 left. 6 divided by 2 is 3. So this will give us 9x. And then this 6 times our -3 is just -18. On our right side, we'll have 5/3 times 6 over 1. Take a 3 out from both. We're left with 10x minus 30 plus 12. if you had wanted, you could have simplified this first and then multiplied by the 6, but it doesn't matter. Now let's add our like terms. So these two, neither of them have an x, so we can combine them. So we have 9x minus 18 equals 10x, and negative 30 plus 12 is negative 18. And now it doesn't matter whether you move the x's to this side and the numbers over here, or the numbers on this side and the x's over here. It doesn't matter. So I'm just going to pick away. So let's go ahead and subtract our 9x. And notice we're subtracting because it was positive here. There's no sign, it's positive. So we're left with negative 18 on this side. 10x minus 9x is just x, then minus 18. Notice we combined the x's because they're like terms, they both have an x. And now we have to get this x by itself, so add our 18. Negative 18 plus 18 is 0, equals x. And we are done. On this one, it's the same idea. If we were to find a common denominator, what would it be? Well, in our case, it'd be 10, because we have a 5 here, and a 2 here, and a 5 here. So multiply everything by 10. On our right side, at first, this 5 is going to cancel and leave us a 2, so we'll have 2 times a plus 5. But that was only when the 10 went to this one. We still have to multiply this 10 by the 2a, so we'll have plus 20a. On the right side, when we multiply the 10 times the a over 2, the 10 and the 2 will cancel, we're left with 5a, minus, and on the next one, when we have 5 in our denominator multiplying by 10 in numerator, this 5 will cancel out, and this is left with a 2. So we'll have a plus 14 times 2. Now let's simplify each side and get rid of our parentheses. So we'll distribute this 2, and we'll have 2a plus 10 plus 20a still. On this right side, we'll have 5a, and notice you're subtracting this whole quantity. So we still want to do subtracting this whole thing, so let's distribute first. 2a plus 28. And now we'll have to distribute this negative as well. So we'll have 5a minus 2a minus 28. Because that's like there's a negative 1 here, and this negative 1 has to get distributed to everything. On our left side, we can combine our 2a and our 20a to get 22a plus 10. And on our right side, we can still combine a's as well. So I'll have 22a plus 10 equals 3a minus 28. Once again, it doesn't matter whether you move the a's to the left or the right, just to do something different. And you could actually move your numbers first too. So let's go ahead and do that. So let's subtract 10 to get our numbers together. So we'll have 22a equals 3a minus 38. Now move our a's. That 3 is positive, so we'll subtract it. So we'll have 19a equals negative 38. Divide by 19. And a equals negative 2. Alright, this one. We don't have fractions, so we don't have to worry about that. So let's just start with distributing and getting rid of our parentheses. So we'll have 3m plus 12 plus 5. Notice this 5 is not in the parentheses, so it's not getting multiplied by the 3, equals 2m minus 2 plus m plus 19. And now simplify each side first. On our left side, we have 12 plus 5, so 3m plus 17. On our right side, we can combine our m, so 2m plus m is 3m. And then negative 2 plus 19 is 17. Now notice we've got the exact same thing here. If we were to subtract this 3m from both sides, we'll get 17 equals 17. And 17 does equal 17. So what this means is this is an identity or all real numbers work. This is a symbol for all real numbers. And what this means is no matter what we put in for the variable, this is going to work. It's going to come out correct. Because notice our variables canceled each other out, and we're still left with a true statement. This 17 equals 17 is a true statement. Alright, now in this case, remember, it's like we have a negative 1 out front. So we'll have this 3x plus 8 equals 2x. Distribute this negative 1 to both. So negative 5x, negative 5 plus x, because we'll have a negative times a negative is a positive. Now let's combine what we can on that right side. 2x plus x is 3x minus 5. Let's combine our x's. We're left with 8 equals negative 5. Well, 8 doesn't equal negative 5. So this means there's no solution. This means no matter what we pick for our value of x, nothing is ever going to work. There are no solutions that will work in this equation. And now along the same lines, you can solve equations for a specific variable. In our case, we want to solve specifically for r. It's the same idea as before. We want to move everything away from it. So start with anything that's getting added or subtracted. So a minus p equals, and we still have prt. Now notice this p and the t are getting multiplied by the r, so we can divide by both of them. Notice they'll cancel out on the right side. And divide by both on the left. So we're just left with a minus p over pt and r on the right side. Now notice r is by itself. And that is section 5.